friends, Jordy here, and welcome back to my YouTube RStudio series. Sorry for my disappearance for a while. I haven't been posting, just been getting on with work-related stuff, especially relating to crypto and other trading things on the market. Also, I've got new video recording software, and that allows me to put this little box down here. It's a box instead of the circle that I was using in the previous software for the video. And I can put it here in the panel that we're not using, right? Because we don't need to have this pane down here being shown. We've got enough space for everything we want to do already. That software is from the Microsoft Store, and it's just called Screen Recorder Plus. Pretty cheap, and it does what I need it for, I believe. So that should avoid having to move the camera around the screen when it gets in the way of code or stuff in various panels. So I thought we'd do something very specific today. Specific but potentially useful, and that is binding data together, okay? So this could regard binding columns from different data frames together into a single data frame. And the major time that I would use this is, at least in my experience, is when you want to put predictions from a model, such as an LM model. Remember, we used predict brackets on new data or testing data in a previous session. And those predictions were put into a single column in one data frame, and then we want to bind that together with the actual observations. So, for example, imagine you're predicting the sepal length in iris from the, so view iris, that's your flowers. Again, I keep going back to this one because it's pretty short, 150. And it's also on plants and ecology, which is my background. Okay, imagine we want to predict the sepal length, okay, and we want to compare with the observations here, the actual observations. The predictions would have to be put together with the observations in a new data frame. And we can do that quite easily. There would be two scenarios, okay, when you would think about binding data. One would be the one I just described, when the lengths of the data frame would be the same, and that's pretty easy to deal with. Okay, so that would be the same because you'd have one observation for every prediction, or vice versa, one prediction of sepal length for every observation. And so the number of rows would be the same in the two data frames, okay, 150. There is a more complex scenario where that is not the case, and you have different numbers of rows in the data frames, and you might not know how to deal with that. Dealing with that in Excel would be a potential nightmare, depending on how long your data frame is. It's really easy to do in a single line of code in R. So we'll get to that in a minute. Let's deal with the first scenario. Okay, let's just, to show you how this would work with the code that we need for it, we would split this iris up into two data frames. I'll put some of the columns in one and another column in the other. Keep the length the same. So we're going to use the pipe function, and we're going to do select. Let's just take columns 1 to 4 in the first copy. Okay, and so that will just include 4 columns from iris and not the final one. View iris 2. Okay, yep, it's taken the species one out there and kept all the other ones. Let's just copy paste that code and change the 2 to 3 to make our species data frame. And that would just be the 5th column. So remember here that when you use select, you can either write the names of the things that you want to select, and if you have multiple columns, you put C in front of the names. Here you can just select the by the column numbers. Okay, so the column numbers are being used here instead. So that's just got the species there in one column. Not very helpful right now, because this is a this is a pretty small data frame, and B doesn't contain any information about any of these species apart from their names and ultimately the counts. Okay, it's 50 of each. So we want to put them back together. So let's make an iris bound, and then we're just going to do bind underscore calls, and we're going to write the two split data frames together with a comma in between them. Okay, iris2 and iris3 are going to be bound there, and then we're going to view that bound data frame, iris bound, and great, voila, they've been put back together. In this case, it's worked really successfully because we didn't rearrange or anything like that on any of the columns. If you were, for example, to sort this in a specific way, then you would have a problem, okay? Because then the species would not be relate to these row numbers again, and it's using the row numbers to bind the columns together according to having the same row numbers. A useful technique, you know, is always to take the row numbers, or well, partly take them out of the row names and put them as a column themselves. Okay, you can do that if you want to stay safe and make sure that you can always see exactly what that you're maintaining the original row numbers from the original iris. And to do that, it's really easy. We have 150 rows. Okay, so right away at the beginning, you could create an ID column, and that's going to be the new column that we're creating here. And then you can use back arrow seq, okay, underscore len, and then write 150. Okay, so now we're going to view iris again and see what's changed. And yeah, we've assigned the row numbers to this column here called ID. So if we were to do the split, we could include that new column, the ID column, here and here as well, and we would just make sure that they're the same in every case, so that they match and that nothing has gone wrong there. That's just kind of like a little bit kind of maintenance and just making sure that you don't have any errors in organization with your data. So that's a relatively easy case. What about when we're binding data with different row numbers? Okay, I've used this before. For example, I've been given Excel sheets or CSV files that relate to the same kind of thing. Okay, I won't tell you the example that I used because it was part of a bigger project. But let's imagine you've got data on different countries. Okay, and in this case, I'll make up some random numbers, some random data. Let's look at a case where you've got one data frame containing different areas of a country. I'll take Scotland since that's the one I'm most familiar with, you know. And another data frame which contains information about the whole country. Okay, maybe I'll take Scotland and England, two countries. So we'll have two countries. We'll have different areas within those countries. And then we'll have information that corresponds to the entirety of Scotland and the entirety of England. Moving us over to Excel. I'm just using Excel Online for the moment. And we'll make some data frames like how I described, you know, with two individual worksheets. All containing data that correspond to Scotland and England, but with some differences between the two sheets. Okay, so let's see, we've got region, we've got country in this one, country, region. Actually, it makes sense to put country first, because that's a kind of bigger group. Okay, and then let's do the, again, it's just random. I'm making up numbers here. So I might not choose actual places in Scotland. I might say A, B, C, D, just so I don't get in any trouble, like, you know, with anybody. And then we'll have information about the population. Okay, so let's see, Scotland. Let's take, like, for example, let's see, five places, okay, and then copy, we don't need to copy it, we're just gonna put England here, and we'll have 5 rows for England as well, that's 5, and we'll do A, B, C. If I scroll down there, it'll automatically continue it, because no, it won't, I don't use Excel that much, D, E. But if I copy this here into this space here, allow it, it's going to give us A to E for England as well. And I'm not saying population of what, but normally population is humans, but it might be something else. Okay, and let's do 50, 100, 33, 12. 33 is my favourite number, by the way. It's going to come up quite a lot in data frames. Let's say, oh, it's not many people living there, but there's tons of people living here. And then this one's got 200, and this one's got 3, and this one's got 54. Random, but just some numbers that came into my head there. Okay, so the next one, it doesn't need to have any regions in it, because it's only going to be information about each country. Okay, so we want to make sure, of course, that we have country spelled the same. And then let's do some, what would you like it to be on? Firstly, let's put Scotland and England as the 2 rows, data rows. This is like, for example, price of cattle. Okay, and I won't put units, but we'll put like 100 and 200 here. Okay, so as you can see, there's information about Scotland and England in both. The differences are that this data frame is much bigger than the other one, because there's specific population data for each locality. This one's only got information about a different metric, the price of the cattle, in the country's overall, okay, so the countrywide price of the cattle. So as you know, firstly we need to get it out here, and we need to get it into R, both the data frames. So we can, if you're using online, you can just export, okay? Export, download as CSV here. Okay, it's taken that as a CSV file in a downloads folder, and I want to call it something that makes a bit more sense. Okay, so I'll just call this population. That's our population data frame. When you do this, box does not come up online to say, do you want to just do this sheet? It does if you use the desktop version, but it will just take that sheet as a CSV file and not both sheets. Okay, so that means we've got to do the same for sheet 2. Download as CSV, and you notice it says book 2 sheet 2. Okay, call this one cattle price. Okay, let me just put these 2 onto the into the YouTube folder. I made a YouTube folder. Okay, so they're there in the YouTube folder. And we can move on from that, and we can bring these files in. Okay, so I'll move the webcam back here. We're going to bring in the 2 CSV files, population. We're going to call it that, because why not? But you can call it whatever you like. Oh, let me make sure I'm in the right working directory. Yes, I am. Yeah, that was sheer luck, to be honest. Population, don't forget your .csv at the end. Okay, and then let's do the same again, bringing in the other data frame called cattle price. Alright, so both of those are read in from the working directory. I've seen a lot of people still keep the environment tab. If you keep the environment tab available here, okay, then you could just double click on it and you'll see the data. But I always use view. It's just an old habit. Okay, cattle price. So we can view both of these and make sure we're right. Okay, so yeah, 10 rows, 5 rows for each country in this data frame, 5 regions for each country, different populations. They could be populations of, probably makes sense if we say cattle at this point. And again, this is incredibly hypothetical. This has nothing to do with politics or anything like that, or society or anything like this. I made it up. Cattle price. Price of cattle for the 2 countries. Okay, so how would you deal with that? In Excel, okay, it would be difficult. As you know, you would have to have, well, not necessarily. It wouldn't be difficult for the small data frame that we have here, okay? Because it would just be simply a case of scrolling down, okay? Over 5 rows, which isn't much, okay? But you're probably, if you're working on any big project, not going to have a data set that's simply 11 rows. You're probably going to have a data set that's going up to thousands of rows. And you wouldn't necessarily want to do that for all of this. So quicker way to do it in R is with the left underscore join method. Okay, so this is going to be a new hashtag here, left join. Okay, so what we're going to do is we're just going to make a new data frame called bound.df. Is based on, here you're going to choose the largest of the data frames, population, and in the next row after the pipe function comes in clutch again, left join brackets the smaller data frame. And so what it should do is put the hundreds next to Scotland and the 200s next to England if it works. Joining by country. Okay, that's important because there's only one column, okay, that's unique, that's found in both, okay, that's mutual to both, okay, and that is country. That makes it easy to do here. We can add a little bit of code if you have certain columns or multiple columns that are found in both the data frames. You'd have to specify which one you want to join by. Okay, but for now it's done it automatically because there's only one option. Bound underscore df, and here it's done it. It's done exactly what we were able to do here ourselves in Excel, but it's done it fast and it would be very beneficial for big data frames. As a quick note, if you want to specify which column to join by, okay, by equals, and then you put in quotation marks country. And that's done it without giving us this white note, because we don't need this white note anymore. We've told R specifically what to bind by. So let's just make a quick graph of that to finish on a kind of graphical note, and also gives me something to put in the thumbnail. ggplot data equals bound underscore df, okay, AES. X equals, what should we put our X? Let's put X as our region. Okay, yeah, region. Y equals population. Okay, and then, you know, maybe we could just add a, well, we're going to have a geom, probably geom bar stat equals identity. That makes sense. Okay. Let's see what this looks like first. Okay, we've got this regional data in there. Let's do plus facet underscore wrap, squiggly line, the price of the cattle. Yeah, okay. So it's separated by the two prices. We know that this price corresponds to Scotland and this price corresponds hypothetically to England. Okay. I just thought again of a nicer way to present this. Of course, there is only one option for 100 and there's only one option for 200, so this might as well say Scotland and England. What might be nice is to put it all on one facet, as in a single plot, so we don't have that facet panel split going on. What you can do is ggplot, okay, data equals bound underscore df AES. Okay, we'll make a scatter plot this time. Let's do x equals region, y equals population, same as before. But if we put size equals, okay, now we want to put cattle price of cattle as the size of the symbols, okay, on the plot, so that we have circles with different sizes corresponding to price of cattle 100, okay, and price of cattle 200. Remember that because right now I can guarantee that price of cattle is numeric. It will be, because it was only numbers in that column when we brought it in from the CSV. And what it's going to do then is create a legend for the size of the points that goes between 0 and 200 with increments, with intervals. So it's going to think that there's a specific size for 50, 150, and there isn't. So you can overcome that by writing factor, and then it's just going to treat them as groups, which in this case they will be for allocating to the two sizes. One size of point for 100, one size of point for 200. Okay, plus geom underscore point, and we don't need to put anything there. Stat equals identity is unneeded here, and here we have it. Okay. So what might be nice, just as a little side note, okay, we want to put AES in front of this, is to make the points semi-transparent. That way we can make sure they're not overlapping, but I don't think they are. Oh, there is one here, that's why it was needed. It was very important. Okay, and we'll just do a color thing in here as well. Color equals blue. What? So on that note, I'm going to leave it. And I hope this was useful anyway regarding, not regarding the colours, but regarding the possibility using bind underscore calls and also left join for putting data initially that had the same number of rows, and then in the last part with different number of rows into a single data frame, and then graphing it. Please let me know down below in the comments what you'd like us to work on next, and message me if you'd like the script. Have a good one. Bye.